So starting with numericals of alternating current, you can see that in many of the question papers, the fixed question is there from this chapter. Fixed 5 marks numerical is coming from this chapter. In rare cases, we are going to see theory question from this part in 5 marks. That doesn't mean that what we have learned, that is a phasor solution and the analytical solution of your equation, is going waste. It's not like that. In some cases, they are going to be asked for 3 marks. Phasor diagram solution for the equation of series LCR circuit was also asked for 3 marks. But the solid question from this chapter is, that is numerical. Important 5 marks numerical comes from this chapter every year. Every year except 1 year where magnetic effect, moving charges and magnetic effect numerical was seen apart from the 7th one. And 7th one, 5 marks theory question was asked. 7th chapter, 7 marks almost. So I'm dealing with the numericals now. And I'm dealing with the NCERT numericals. NCERT numericals. Fine, from the textbook itself. So you can see, first, already the question is known to you. It is there in your textbook. To my students, I sent already in a group. That is a list of numericals, NCERT textbook, picture only it is, a photo only it is, okay. So question you need to copy from there, question you need to take it from there. Here we are going with the solutions. The first question goes like this. A 100 ohm resistor is connected to a 220 volt hertz AC supply, 50 hertz AC supply. So make it clear, we are using alternating current, so it must be having a particular voltage with a frequency. I said for India 50 hertz is the frequency fixed for our country, that is 50 hertz. So 100 ohm resistor connected to 220 volt resistor, 220 volt power supply with a 50 hertz frequency. Power supply is AC in nature, alternating in nature. First bit, what you need to calculate is what is the RMS value of current in the circuit. RMS value of current in the circuit. And the second bit is what is the net power consumed over a full cycle of alternating current. As they are saying about the numericals here, I am showing you that this is a numerical one. Solution given, they have given the 100 ohm resistance, that indicates it's a purely resistive circuit. So power, surely it is going to be there, power dissipation will be seen. And what they are saying, what they are giving the power supply of voltage 220 volt. I said for India the voltage is 220 to 240, 220 in the 240 vargu irutte range anta. So the frequency is given, that is F is equal to, or let me write the nu as the symbol, so that is 50 hertz. So what is the first bit question? They are asking us to calculate IRMS. They are asking us to calculate IRMS, make it clear. And they are asking us to calculate the power. So what is IRMS? Very simple formula, students. Very simple formula. IRMS is equal to VRMS by R. From your Ohm's law only, V is equal to IR, or IRMS is equal to VRMS by R. Substitute the values. Substitute the values and simplify. 220 by 100. This comes to be as 2.2 ampere. 2.2 ampere. Make it clear, 2.2 ampere. 2.2 ampere is the root mean square value of current. Whenever they mention the supply voltage, that AC supply voltage along with the 50 hertz frequency, you need to take it as a VRMS. You are not supposed to take as a V0. You are not supposed to take it as a V average. Whatever they are giving as an AC main supply anta elli mention agutte, adu VRMS value ne irutte. Peak alla, average alla. You need to take it as a VRMS. So using that, calculate the IRMS. Here is your solution. Very small bitwise combined in one question, it will be seen in this kind of questions. Numericals of this chapter includes many small formulas, small bit solutions togetherly combined in one question to make it as a 5 marks question. Power, very simple thing. What is the formula for power in case of your Pure resistive circuit we learnt in a previous class, yesterday's class only. VRMS into IRMS. That's it. Very simple steps. VRMS 220, IRMS 2.2. So what you are going to get as the final? So answer is supposed to be, you're going to get that 484 watt. Check well. 484 watt. The power dissipated in this circuit is 484 watt. Multiply 2.2 with the 220. So very simple thing, students. Let me write one more step for your convenience. This 0, if I multiply with this, it becomes 22. So here is your numbers without decimal point. 22 into 22, 484. 22 into 22, 484. This is your first numerical from NCERT. First numerical from NCERT. Resistance is given. The RMS value of voltage and the frequency has been given. They are asking us to calculate the current in root mean square values, and they are asking us to calculate the power dissipate. Hope it's clear. Go through well enough. Then we'll go with the second numerical. Second numerical. I request and hope that students needs to solve simultaneously with me. To make it clear, you are supposed to solve simultaneously. There should not be time lag for the copying purpose. Okay, as I will be rubbing. So this is your first numerical. This is your first numerical. Let us go with the second one. Before rubbing this, I want the students to look this. Observe this carefully. This is your first formula. IRMS is equal to VRMS by 2. Substitute the values. Simplify. Power formula in second bit is, this is your formula. Multiply. To remove this decimal point, I just adjusted with this 0 and multiply. You're going to get this value 484 watt. Make it clear. So I will go with now second problem. Second problem. We are going slowly so that students can solve simultaneously with me. Second problem. It's already in the bitwise question only. First bit. The peak voltage, see, if it is not a RMS value, they are going to mention whether it is a peak or average. If they won't mention peak or average, you are supposed to take it as a PRMS. Okay, make it clear. So, first bit, the question, in the question, the first bit itself is the beginning of the question. The peak voltage of an AC supply is 300 volt. We learned that peak we have taken as a peak we have taken as V0, 300 volt. 300 volt is the peak voltage of an AC supply. What is the RMS voltage? In the first bit, what they are asking? What is VRMS? Okay, the next bit, second bit. The RMS value of current in an AC circuit is given. You need to find out the peak value. IRMS is given. IRMS value is given, that is around 10 ampere. And the B bit asks you to calculate I0. What is the formula relating your peak and average values? Not average, peak and RMS values. VRMS is equal to V0 by root 2. V0 by root 2. Relation between peak and RMS value. V0 300 root 2 1.414 multiply 212.1 volt. 212.1 volt. 212.1 volt when you are going to divide, you are going to get 212.1 volt as the RMS value of voltage. RMS value of voltage. Make it clear. Then I0, same formula, only in case of I0, V0, VRMS, IRMS. So formula comes to be as IRMS is equal to I naught by root 2 and cross multiply because we want I naught. I naught is equal to root 2 into IRMS. Just now I said you can remember the value of I naught, this root 2 common ones 1.414 it is into the value of your given IRMS is 10, so it becomes 14.14 ampere. Peak current is 14.14 ampere. Peak current is 14.14 ampere. I am repeating this numerical. First bit, it starts in the beginning of your second question. The peak value of AC supply is 300 volt. Calculate the RMS value. Calculate the RMS value of voltage. And second bit in this question is the root mean square value of current is 10 ampere. Then find out the peak current. This is your formula relating to it. These are your givens. Substitute, simplify. You're going to get 212.1 volt as a root mean square value. 220 nearby. Okay. Then similarly using the similar formula in place of VI is replaced. So we want the I naught, so cross multiply root 2 or root 2 into IRMS. Root 2 is 1.414 into 10 becomes 14.14 ampere. 14.14 ampere. Hope it is clear. This is your second numerical from alternating current. You may be thinking that these are very small, very less steps involving numericals, but as you are going for the further sections, means further numberings, the number of formulas used are going to become more, up to 5, 3, 4, 5. Sometimes you are going to use those many formulas in one question, that is a one numerical. Here we have used two formulas. In previous also we have used two formulas, right? Smaller formulas. You can understand in a previous problem 50 hertz frequency was given, which was not used anywhere. It was only for confusing you. 50 hertz voltage, 220 volt, 50 hertz was given. Alternating current characteristic values are given, but 50 hertz were not used anywhere. It was not used anywhere because the formula doesn't involve that. Now I will go with the third numerical from your NCERT. Third numerical from NCERT. As I said, students are requested to do the numericals simultaneously to avoid the time to copy it. To avoid the time to copy it. The third numerical. A 44 millihenry inductor is connected. 44 millihenry inductor is connected to a 220 volt 50 hertz. Try to understand now. Again 220 volt 50 hertz comes. As I said you, 220 volt 50 hertz when they mention without any suffix as a peak, any what you can call as a specialization as a peak or average, that is VRMS value if it is not mentioned. 220 volt 50 hertz, this is a fixed practically correct value which we are using in our day to day life. ಸುಮ್ಮನೆ ನಂಬರಿಂಗ್ ಕೊಟ್ಟಿರೋದಲ್ಲ, ನಾವು ರಿಯಲ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂನೇ ಅದು. 220 volt 50 hertz AC supply. Determine the RMS value of current in the circuit. Determine the RMS value of current in the circuit. By taking the help of inductor value, we need to calculate the RMS value of current. RMS value of current. So what are the formulas? I said in this chapter we are using many small formulas in one numerical. Okay. Inductor is given, L value. How much is the inductor value? 44 millihenry. Convert the millihenry. It becomes 44 into 10 to the power minus 3 Henry. And voltage, that is a VRMS, 220 volt. And the frequency is 50 hertz. And what they are asking is to calculate IRMS or peak. Determine the RMS value of the current they are asking. RMS value of the current in the circuit we need to calculate. Look at the board very carefully. The formula for IRMS can also be written as IRMS is equal to VRMS by XL. Before solving this numerical, I want you to understand this. R can be written as VRMS by IRMS for pure resistive circuit. XL can be written as VRMS by IRMS for pure inductive circuit. And XC can also be written as VRMS by IRMS for pure capacitive circuit. Okay, pure capacitive circuit. Here XC is nothing but omega L. Here XL is nothing but omega L. Here XC is nothing but 1 by omega C. And let me make you clear, omega is nothing but 2 pi nu L. 2 pi nu L. Here that similarly 2 pi nu C. 1 divided by here. I'm giving you this formula list. You can see it has become a list of formulas only in this section. Why I want you to understand is we are using this. You should not get confused that in previous problems also we used R is equal to VRMS by IRMS. Now we are taking XL is equal to VRMS by IRMS cross multiplied, it gives VRMS by XL. So if you want, calculate the XL separately and substitute, or else go on substituting the simplified formulas, then you substitute the values. So I am doing that. I am writing the formula. For XL I am separately calculating, that is 2 pi, or let me show you that omega L barutte, that can also be written as 2 pi nu L. So XL value becomes 2 into 3.14, 2 into 50 into 44 into 10 to the power minus 3. It is in ohm. It is in ohm. Just check it out. 50 into 2 becomes 100. 100 into 3.14 becomes 314.2 into 44 into 10 to the power minus 3. You have the calculators with you. Simplify well and say the XL value becomes 13.83 after taking that 10 to the power minus 3 also. After taking that 10 to the power minus 3 also, means you are going to get 1,38,000, not 13,000. 13,830 you are going to get when you multiply 314.2 into 44. Then taking this 10 to the power minus 3, 3 digits we are shifting, it becomes 13.83. One more digit may come after the 3. This is in terms of ohm. Use this value here now. VRMS is 220 and this is 13.83. This comes to be as IRMS, which we need to calculate now. The value after dividing comes to be as 15.9 ampere. Check well using your calculators. Check well using your calculators. 15.9 ampere is the answer for your third question. You may be feeling these are very simple and smaller and less in steps. Yes, I agree. These are also asked for 2 marks sometimes. As many small questions combine bitwise questions, then it becomes a lengthier and it becomes a 5 marks important question. So this was about the third numerical. Similar ones in case of XC. Similar ones in case of XC. I will not drop this and I will give you the next question as your classwork. Do it in 3 to 4 minutes, maximum 5 minutes. Maximum 5 minutes. The question is, a 60 microfarad capacitor is connected. In case of inductor, capacitor is given C. It is 60 microfarad, 60 10 to the power minus 6 farad. 110 volt, 60 hertz. 110 volt, 60 hertz. 110 is VRMS given here. 60 hertz is the frequency given here. So find out the RMS value of current, the same question. Same question, instead of Excel, we are using XC. Instead of Excel, we are using XC. Make it clear? I hope you will do it.